In this video, we are going to be discussing speed, time, distance problems. So in other words, we're going to be talking about how speed, time, and distance relate to each other. So I'm sure you're well aware of what speed is. Speed is how we measure how fast something is going. And speed is always measured in a distance per time. So one of the more common ones that we use in the United States is miles per hour. That's typically when you're driving in your car, that's how you would measure your speed, is miles per hour. But if you live in a European country, there's actually a lot of places across the world that don't use miles and they use kilometers. So if you've ever traveled abroad, maybe you notice that they use kilometers per hour instead. So that would be another measure of speed, would be kilometers per hour. Another one you might see is feet per second. Right, and there's plenty other ways to measure speed, right? As long as you have a unit of distance and then a unit of time, pretty much any combination you can think of could be used as a measure of speed. So the speed time distance equation, we have three variations of it, and they're actually all three the exact same equation. It's just rearranged depending on which unit you're trying to find. So if you're trying to find distance, you'd use the first one. If you're trying to find speed, you'd use the second one. And if you're trying to find time, you'd use the third one. Let's look at a couple examples where we would use one of these three variations of the formula. So this first example here, we're given that a person ran for 30 minutes at a pace of 10 miles per hour, and we want to find the distance that they traveled. So one thing that we notice when looking at this one is that the speed is given per hour, but the time they ran is given in minutes. So we want to make sure that we get those both in the same unit. So since speed is per hour, we're going to convert the 30 minutes to hours as well. 30 minutes is half of an hour, so we can write that as 0.5 hours. All right, so now that we have our units all consistent, we can figure out which formula we want to use. So we are trying to find the distance. So we're going to use the equation that's solved for distance, and that's going to be this first equation here. All right, so distance equals speed times time. So our speed is the 10 miles per hour. So 10 miles per hour. And then we need to multiply that by the time. And the time is 0.5 hours. So 10 times 0.5 equals 5. And distance is measured in miles in this case. So we say that our distance is 5 miles. Let's look at another example. So example 2 here, we're given that a ball is thrown at a speed of 40 feet per second. We want to find the time that it took to travel 168 feet. Notice that in this question, we're being asked to find the time. So we want to choose the equation that is solved for time. So that's going to be this third equation here. Time equals distance divided by speed. So time equals the distance it traveled. It said it traveled 168 feet. So we'll do 168 feet and then divided by the speed. And the speed is 40 feet per second. Right, so we need to divide 168 by 40. So we'll do some scratch work off to the side here. 168 divided by 40. The first thing I want to do is I want to simplify that fraction a little bit. So 168 divided by 40, those numbers are both divisible by 4. So if we divide both those numbers by 4, 168 divided by 4 is going to be 42, and then 40 divided by 4 is 10. Now the nice thing about dividing by 10 is you just move the decimal one place to the left. So 42 divided by 10 is going to become 4.2. Right, so this means that the time that it took for the ball to travel 168 feet is 4.2, and our time is in seconds.